Okay, so this is a quick refresher for right angle triangles. This is what we covered in class on the very first day in September. So when we're working with right angle triangles, we can identify them because they always have one angle as a right angle, and that means it's 90 degrees. It's indicated by this square shape there, and you'll find that whenever we're working with these kinds of triangles. Now, when we label the sides, what we do, the first thing we do is we find the angle that is the right angle, and we go opposite of it. We go opposite until we hit a side. That side is called our hypotenuse. Okay, that's always going to be opposite of our right angle. Note, in this triangle as well, it's the exact same side, hypotenuse. Next, we're going to label the final two sides according to which angle we're working with. So in these cases, we'll always work with one angle. Here, I'm working with the angle from here. So I go opposite of this angle to find my side that I call opposite. What it's opposite to is theta. It's opposite of theta. And the side that's beside theta right here, we call it the adjacent side. Adjacent means beside, so it's adjacent to theta. So let's notice that if our angle, theta is in another corner, say here, then we're going to be labeling the other two sides differently. So here, I go opposite this theta to find my opposite side, and I go beside my theta to find my adjacent side. Now, there are three trig formulas that we're going to be working with. You can remember them by the common trigonometry phrase, so, ka, toa. That means that the sine theta formula equals opposite side divided by the hypotenuse. All of these formulas are built the same way. It means our cosine of theta right here equals our adjacent side length divided by our hypotenuse side length. And that means our tan theta equals our opposite, that O stands for opposite, divided by my adjacent side length. Now, when we're finding the side length of these right angle triangles, the first thing we're going to do is just that. We're labeling the sides. Hypotenuse, adjacent, and opposite. Then we're going to choose our trig formula, which will be one of these three. Our sine theta, our cos theta, or our tan theta. Remember that by so, ka, toa. After that, we're going to substitute in our known values. And then we calculate our trig function using the calculator. That's either calculating our sine of theta, or cosine of theta, or tangent of theta. Finally, we'll isolate the unknown side length. Now, the only trick here is when we're choosing our trig formula, and I'll walk you through that one here in a moment. So the first thing we do, if we're solving for missing side length here, then like we just went over, we're going to label our sides. Well, I see one angle that we're working with. It's not marked by theta here, it's marked by 40 degrees. So I go, and let's see here, and I see my 90 degrees right here. So the first thing I do is I take my 90 degrees and I go across the triangle to label my hypotenuse. Then I take my 40 degrees and I go across the triangle to find my opposite side. And then I go beside my 40 degrees to find my adjacent side. Perfect. So now that I have labeled the sides here. Then I'm going to choose my trig formula. So I can either choose the one that has sine in it, the one that has cos in it, or the one that has tan in it. Well, my method for doing so is going to be to look at the two sides that I currently am working with. So here, I notice my adjacent side. That one's not labeled by an X, and it's not labeled by a number. So that one is not very useful to us. But we notice our hypotenuse side is labeled by a number. We know the length of our hypotenuse, and it's 12. I know that my opposite side is labeled x. That's what we're looking for. So we're going to want to make sure that both of these sides are in the formula we choose. So we're going to choose the only one up here that has opposite and hypotenuse. We notice our cosine theta has adjacent and hypotenuse, so that's not it. We notice our tan theta doesn't have a hypotenuse in it, but our sine theta here has sine theta equals opposite over hypotenuse. So that's going to be the one we choose. We'll always write out the formula here. So sine theta equals opposite over hypotenuse. So we have now chosen our trig formula. Now we're going to substitute in our known values. Well, I know that my theta equals 40 degrees. That's right here. So I can say sine 40 degrees. My opposite is an unknown. That's x. My hypotenuse is of length 12, so I can substitute in the number 12 there. Now I can, so I've done that, I've substituted in my known values. I can calculate my trig function using my calculator. So I can grab my calculator and I can find the sine of 40 degrees. My calculator says that is 0.64 equals x divided by 12. Perfect. So I've calculated. Now I need to isolate the unknown side like x. Perfect. So I have an x here on the right-hand side. Right now it's being divided by 12. So in order to get rid of that, I'm going to multiply both sides by 12. I'll notice on my right-hand side, those cancel out, leaving me with an x on my right-hand side and 12 times 0.64 on my left-hand side. So I can put that into my calculator now. 12 times 0.64 equals 7.68. And that's how I find the side length. So my side length x here equals 7.68. Now we're going to try one more way here. We'll follow the same steps, 1 through 5, but this time we'll notice that it's set up a little bit differently, and that means isolating it will take a little more work. So first we're going to label our sides. So we find our right angle, that's right here. We go opposite to label our hypotenuse. And then we find our other angle, that's right here. We go opposite to label our opposite side. And we go beside the angle that we know to label our adjacent side. So here I have my hypotenuse, my adjacent, and my opposite. Well, my adjacent side has the unknown, so that one I will need in my trig formula. My opposite side I know has a side length of 9. So I'm going to, I'm trying to do this in green here. Has a side length of 9. So what I'm going to do here is choose my trig formula that has both an opposite side and an adjacent side. Now I notice here that that my sine formula does not have an adjacent side, so I can't use that. My cosine formula does not have an opposite side, so I can't use that. Meaning my tan formula has both opposite and adjacent. We'll use that. So I'll write that down right here first. Tan theta equals opposite over adjacent. Perfect. Now I can substitute in now that I've chosen my trig formula, I can substitute in my known values. Well, I know that theta equals 34 degrees. I know that my opposite side has length 9, and my adjacent side is my unknown, that's an x. So I've done that. Now I'm going to calculate my trig function using a calculator. So I'm going to grab my calculator and do the tan of 34 degrees. That equals 0.67 equals 9 divided by x. Now this time I notice my x is in my denominator. That's on the bottom part of my fraction. So that means what I need to do is, when I'm isolating it, is I need to get it to the top. So in order to get it to the top, what we'll do is we'll multiply both sides by x. Notice on my right hand side, my x's actually cancel out, but that's okay, I still have one here. I'm left with a 9 on my right hand side and 0.67x on the left hand side. We'll continue up here. 0.67x equals 9. Now this looks the same way my problem looked that I did previous to this. I need to isolate for my x. Right now it's being multiplied by 0.67, so we'll divide it by 0.67. If I do that to the left, I need to do it to the right as well. And they cancel out on the left, giving me x equals 9 divided by 0.67, which I can put in my calculator, is 13.4. So that's how I do it when I find my x is in my denominator here, like this, and my first method was used when my x is in my numerator. That's how we'll do it, and we can use that throughout the unit.